Hey guys, so here is part 3 of the 5.8 day 1 notes. We're going to continue to sketch functions, and really mainly these are going to be in factored form. Okay, so here, once again, we are in factored form. So to find our degree, we need to count the exponents. Okay, so notice on the x minus 2, that is an exponent of 1, and same thing on the x minus 4, that's an exponent of 1. So I have 2 plus 1 plus 1, and that gives us 4. Now that is an even number. So we have an even degree here. Now to find the leading coefficient, remember that is going to be the number in front. Though we don't see a number, remember that means that's an assumed 1. So our leading coefficient is 1, and that's a positive. So when we determine the in behavior, remember with even degrees, the arrows go the same way. And so because our LC is positive, the arrows will go both up, okay? Now, let's talk about our x-intercepts. So our x-intercepts are going to come from the factors. So x plus 1, x minus 2, and x minus 4. So I have x plus 1 equals 0. And when I solve that, I get x equals negative 1. Then I have x minus 2 equals 0. Then I get x equals 2. And then x minus 4. And I get x equals 4. Now let's talk about if we bounce or cross. Remember, we look at the multiplicity for this. So on the factor x plus 1, the multiplicity is 2. So since we have an even multiplicity, that means we are going to bounce. Okay? Always look at the multiplicity, not the x-intercept. Now the multiplicity on the factor x minus 2, which we get x equals 2 as our x-intercept, that multiplicity is 1. That's an odd number, so we're going to cross at that x-intercept. Now, lastly, on our factor of x minus 4, the multiplicity is also 1. That is odd. That means we also cross, okay? Now, before we plot these points, let's find some other points so we can be a little bit more specific when we sketch this function. Now, I have once again given you x values, so go ahead, fill this out onto your notes. Remember, on your homework assignment, I have already given you the x values on the xy table. And so now what we're going to do is take these values, plug it back into the original function to get the y values, okay? Okay, let's start with negative 2. So we're going to do f of negative 2. So the function we have that we're going to plug into is x plus 1 squared. So any place I see x, I need to plug negative 2 in. So I have negative 2 plus 1 squared, not equal, times, then our next factor is x minus 2. So I'm going to have negative 2 minus 2. And then our next factor is x minus 4. So that's going to be negative 2 minus 4. So once again, we're just going to use our calculator to plug this whole thing into it to make it easier on ourselves. Okay. And then you go back, so anytime you need to quit, do second mode. That's what that means, quit. Okay, so I do negative 2, make sure you use the negative sign, then plus 1 squared. Okay, then I do negative 2 minus 2, and then negative 2 minus 4. And press enter. I get 24, so I'm going to write that in my XY table. Now remember, if I'm going too fast, always pause the video, okay? Next, let's try 0. So I'm going to plug 0 for every place I see x. Basically, you're replacing all the negative 2's with 0 now. So I have 0 plus 1 squared, 0 minus 2, and 0 minus 4. Let's go ahead and plug this into our calculator here. And then 0 minus 2. Make sure to notice that for each factor, I am using parentheses. I get a positive 8. Okay, let's put that into our XY table. Now I'm going to do the same thing with my 3. Plug that into every single value for x. So I have f of 3. So I do 3 plus 1 squared, then 3 minus 2, then 3 minus 4. If you want to try to plug these into your calculator yourself just to make sure you're doing it correctly, you can definitely do that. It's a great way to do a self-check. And then 3 minus 4. and press enter. We get negative 16. Okay, I'm going to plug that in. And then lastly, we have 5. So I do f of 5. So I have 5 plus 1 squared, 5 minus 2 times 5 minus 4. 5 minus 2, and then 5 minus 4. And we get 108 there. Okay. So now we're going to go ahead and plot our points. Now, as I said, in your homework assignment, it will tell you what you should go by on your y-axis. Your x is going to stay by 1s because we can definitely do that. But your y's will kind of have to change. So here I'm going to do the same thing. So our largest is 108. So I'm actually going to go by 10s on the y values. Okay, go by 10s. Okay, we could probably have also gone by 15, but that kind of got a little bit big. Maybe 12 would have been a little bit better. But that's a little bit harder there, right? Well, let's see, what do we have? So we do have 24, we have 8 and negative 16. We could go by 12s. Let's go by 12s. That's a little bit easier because we'll definitely have 108 as our largest value. So we'll go by 12s. On the y-axis, okay? Okay, so let's go ahead. I'm going to first plot my x-intercepts. They're the easiest to do. So I have negative 1, so that's negative 1, 0, 2, 0, and 4, 0. Perfect. Now, negative 2, 24, so this is easy. So I go over 2 to the left, and then I go up, because I'm going by 12, I go 12, and then 24. So I plot there. Now, 0, 8. This one we have to be a little careful. So 8 is smaller, so I will have to kind of put it maybe in between. That might just be a little bit easier there, okay? Then I have 3, negative 6, so I go down 12, and the next one is 24, so I'm going to just put it in between the negative 12 and negative 24. And then lastly, we have 5, 108. So there, oops, we should go up all the way. Don't think at there, it would be one more at 9. Okay, yes. So 12 times 9 gives us 108. Now, you might be wondering, how are we supposed to connect all of these, okay? Well, what we can do is actually graph this function, kind of help us out to know. But we can also kind of maybe just sketch it first and then use our calculator to see if it looks good. Well, first of all, we know we have to have arrows. So we're going to connect this like if you're connecting the dots. So I go left to right. So my first arrow needs to go. Now I go here. Now we are going to use the cross and the bounce on our x-intercepts, okay? So notice that at x equals negative 1, we are going to bounce, okay? So I'm going to bounce on the x equals negative 1. Now I do need to probably go back up and hit the next point, okay? Now, on my next x-intercept of x equals 2, I'm going to cross that. So I'm going to come back down probably to see if that works, okay? So maybe I'll come back down here, I'll come back here, and then go all the way up, okay? Now, we're going to see if this kind of looks like what our graph will look like. If not, that is okay. We're going to graph it. And if we need to make any changes, we can do that, okay? So I'm going to go to my y equals. Don't forget, if you need to get rid of this, I just clear it. Boom. Okay, so we have, I think, let me go back to the function. There we go. We have x plus 1, and we square it. Oops, clear that, make it right. X plus 1. So remember, the x is going to be right next to the alpha key, if you did not know that. So we have x plus 1 squared, then x minus 2, and then x minus 4. Okay, and we can just use this to double check that we kind of graphed this correctly. There is a possibility that we have to go back down, through, and again to make this look right. Okay, so let me graph it. Okay, so it looks like we go down. We did that correctly. Okay, we do go up because that crosses. So it looks like we go through it and we come up a little bit, which we're going to add that next and then come back down and down. So this little area, what I'm going to do is I'm going to go back up a little bit more and then come back down, okay? Now remember, this is a sketch, so it doesn't have to be exactly no, okay? So I'm going to get rid of this. I did go through the X or Y intercept correctly, but I'm going to go up a little bit more and then come back down. There you go. So that little hump that we have in between, you know, that's not very specific. So that's why this is still more of a sketch than an exact graph, okay? Now we did this correctly because we noticed that the end behavior is the exact same. So we have both up. We used our multiplicity to know when to bounce and to cross through the X-intercepts. And then we can use the graphing calculator just to see if it looks similar, which it does look similar here, so that works out perfectly, okay? We're really just making sure we get the general shape of the graph. That's the whole idea. Okay, now the last thing we need to do is talk about domain and range. Now, first thing, don't forget domain of every single polynomial function is going to be negative infinity to positive infinity. Now, because our degree is even, that means we do have what is called a local minimum. Now, we're going to be talking more about local max and mins in our 5.8 day 2 notes. But basically, your local mins and max are going to be either the bottom or top of our, what we call like our little humps. Now, we are going to have a more specific name than just saying they're humps or little hills. Those are going to be called turning points. And we'll talk more about that in our next section, 5.8 day 2. So local mins are going to be the lowest point of these little humps here, okay? And then the local max, that's going to be the highest point on these little bumps. So what we want to know, because we have an even degree, is we are going to go from the smallest local max, or local min, excuse me, and then we're going to go towards positive infinity since our graph is opening up or the arrows are going up. So we are basically finding what is the smallest y value on our graph. So the smallest y value is actually going to be this point here. This point was 310, or negative 10, or sorry, it's going to be, let me rephrase that. This is 3, there you go, negative 16. There you go, okay? So that is our lowest point that we have here. So negative 16, that's what we want to use because we are thinking of the y values. So we're going to have negative 16, so we use bracket there. And then we're going to go to positive infinity because the arrows are facing up. So all the y values are getting bigger than negative 16. So we want to always go from the smallest y value to the largest y value. And so our smallest y value is negative 16, which we got from our XY table here. And as the arrows continue to go on forever in the up direction, they're always increasing. So we use positive infinity to represent that. So this would be our final answer here. Okay? Okay, make sure you guys work on the homework assignment, and if you guys have any questions, make sure to contact me. I'll see you guys later.